So today I posed the question, can you find the sum of a sequence of numbers that's infinite? If it never ends, how can you add it all up? Let me show you. Okay, so this problem is asking me to add up this sequence that begins 9 plus 3 plus 1 plus 1/3 dot dot dot. So first thing we want to do, we want to ask ourselves, is this an arithmetic or a geometric? All right, so if I look at the arithmetic difference, the common difference, I can see that I have nothing common. This is not arithmetic. However, if I take any given term and divide it by the term that came before it, 3 over 9, 3/9 or 1/3, 1 over 3, 1/3, 1/3 over 1, 1/3. This is my common ratio. That means if I take any term and multiply it by this common ratio, I get the next term. So we could predict the next couple terms. 1/3 times 1/3, 1/9, 1/9 times 1/3, 1/27th, 1/27th times 1/3, 1/81st, and so on and so forth. And you can see that very quickly we are getting very small, which means as we continue doing this, the terms we're adding will get smaller and smaller until essentially it's like adding nothing. And that is why in the very specific case, when your common ratio is between -1 and 1, in other words, when it is fractional, then you can sum an infinite geometric sequence. And there's a formula for it. So that looks like this. The sum of this sequence will be our first term divided by 1 minus the common ratio. So in this case, that looks like this. 9 divided by 1 minus 1/3, or 9 divided by 2/3, which, don't ask why, just flip and multiply, becomes 9 times 3/2, or 13.5. And if you were to go ahead right now and put just the numbers we have on the screen into your calculator, we would already be at 13.49382716. And you can imagine if we kept adding tinier and tinier and tinier bits, we are going to essentially have 13.5, because at some point what we're adding will become negligibly small. All right, so there is your answer to, can you sum a series that is infinite? The answer is yes, when it is a geometric series and your common ratio is a fraction, is between -1 and 1. All right, have fun with that. Check out my other videos on sequence and series, my Algebra 2 and Pre-Calculus playlist. Leave any questions you have in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.